There's an important specification point for the GCSE chemistry that I want to highlight in this short video. It makes it very clear in the specification that you need to be able to make estimations about uncertainty, and it says that you need to use a range of a set of measurements about the mean as a measure of uncertainty. Now, it's not entirely clear what that means, I think, for people. I think it's worth highlighting that, and I'd say that I've taught this wrong in the past, and some of the resources we use or have used at school have been wrong too, and I'll show you how we know that and how we should handle it properly. Now, if you've, as it says here, you take a measurement with a piece of apparatus, there's some uncertainty associated with that. If you do the experiment multiple times, you'll get a different result each time around the mean. Okay, so for example, take a measurement 21 degrees C from this thermometer, but if you did that experiment lots of times, you'd expect to get data that falls within 23 or 19 to 23, 2 degrees C either side of 21. If you do it lots and lots of times, you can work out the mean, and you can remove anomalies and all that kind of stuff that we've done plenty of times. But working out the uncertainty is a bit more tricky and worth pointing out. I'll highlight now that in your revision guides, and I've got one here to show you, the uncertainty is shown as uncertainty is range divided by 2. Now that's just wrong. I put a cross through that. It's also wrong in your the textbooks that we have at school, the Oxford ones. It is correct in the Hodder textbook, and it is correct on this worksheet I'm about to show you. And I'll show you how we know that from a previous exam paper towards the end of the video. What you would need to do is exactly as set out in this example here. So it says here that the volume of gas produced in a reaction was measured 6 times. This was the data generated. What you do is first of all look at that data and see if there's one piece of data that looks really different from everything else, and there is in this case. 61 is a long way from everything else, so that must be an anomaly, and you'll get credit in an exam for highlighting anomalies and then working out the mean using the remaining data. So these 5 data points are added up, divided by 5, and you get 79 centimeters cubed, and it's appropriate to round it to 2 significant figures because all of the input data is 2 sig figs. Okay, right, so the range then is, the lowest number is 71 and it goes all the way up to 83, so that's your range, and the mean is 79. So how do you work out this value here, the uncertainty? And what you need to do is to see what the biggest difference is from your mean to the bottom of the range and the top of the range. The difference between 79 and 71 is 8 centimeters cubed. The difference between 79 and 83 is 4 centimeters cubed. The uncertainty, therefore, the biggest uncertainty is therefore 8 centimeters cubed, and that is the correct answer for uncertainty for this experiment. Okay, let's do another couple of examples with you. So this is the worksheet you've been given. Here's some data you've got. In fact, I'm going to do question 2 because there's no anomaly on question 1. I'll highlight now, by the way, that if you go about this in the same way as set out in the revision guide, you will get the wrong answer, the wrong value. Okay. I'll do question 2 next because there is an anomaly here. This value here is really quite a long way from the others, so we're going to ignore that one and take the mean of these 3 values here. So we add together 24.2, 24.4 and 24.1, and then divide all that by 3 and you get 24.2, and the range, which I would highlight in an exam paper, so 24.2 centimeters cubed to 3 sig figs, the range is 24.1 to 24.4. The biggest difference from the mean to the extremes of the range is 0.2 centimeters cubed and 0.1 centimeters cubed. So the uncertainty is plus or minus 0.2 centimeters cubed, which is the largest of those 2 numbers. So 24.2 plus or minus 0.2. And again, if you'd have done this the way that the revision guide that you've got says, you'll get half the range is plus or minus 1.5, which doesn't make a lot of sense here. Okay. So question 3 is the last one I'll do with you, and then I'll show you where this is found in an exam paper. So question 3, you've got volume of gas formed. You've clearly got an anomaly here. This is well away from everything else. Add together the other 5 bits of data and divide by 5. Round to 2 sig figs, you get 68 centimeters cubed. So the mean 68 centimeters cubed. The range, and I would work all this out on your exam paper. Show the examiner you know what you're doing. The range is therefore from 64 all the way up to 75. And it's a weird one, it's got an odd number there, divide that by 2, you get something and a half. What do you do next? Not that clear. But from mean to the extremes of the range is 4 centimeters cubed and 7 centimeters cubed. So the answer, the uncertainty is plus or minus 7 centimeters cubed. So it's 68 plus or minus 7 centimeters cubed. Now this is an exam question from 2023. Here's an example of sort of proving the method that I've just shown you is the right one. So in this question, what happened is a student had to measure a bunch of temperatures to see what the temperature drop was in an endothermic reaction. And they worked out for you, in the question it works out the mean for you, which is 16.5. There's no anomaly in here. And it tells you that the uncertainty is plus or minus 0.3, but you have to explain why it was plus or minus 0.3 degrees C. And most people, it says very clearly in the examiner report that very few people got the marks for this because they said that it was half the range, which it is. But what you have to say here is that you have to say that 0.3 degrees C is the uncertainty. You have to just state, it doesn't say it anywhere in the question, you have to say that is the uncertainty, and that actually got, believe it or not, a mark. And the way that you define it, and this is what we need to practice and work on, is that the uncertainty is the range about the mean. And it makes it very, very clear that's what it is in the mark scheme. And I'll read the examiner report now to you. It says, this question was not well answered, with fewer than half the students obtaining a mark. Many students were able to explain the range was the results ranged from 0.3 below and 0.3 above the mean. However, very few said that it's the uncertainty itself, and very, very few it says or makes clear that it's half the overall range, and that's not okay. You needed to say that it's the range about the mean, in other words, how far the data is from the mean. Hopefully that's clear enough, and I'll stop talking.